Hey everybody, welcome back to the Print 3D channel. Today is December 7th, and that means day 341 of the 3DP 365 project. And on today's episode, recently, Martine from 3DP Iceland sent over a really cool care package. Inside was some Haribo candy and a really cool landscape that he had custom printed and painted on his channel. In the unboxing video, I replied back that we were going to do the same. We were going to find a spot in America, or in North America that is, that we would print out and then paint. And I found a really cool program called Terrain to STL from some of my subscribers that'll generate STL files from anywhere in the world using Google Maps. And we generated Mount Rainier. And our print turned out really cool, and I can't wait to share it with you guys, so stick around. Hey everybody, welcome back, and thank you for joining me here for day 341 of the 3DP 365 project. As I was saying in the introduction, Martine over at 3DP Iceland had sent over a really cool package. And inside was this really awesome landscape that he had 3D printed and painted on his channel. And I thought it looked really cool, and I wanted to do the same. I wanted to find a really cool area in North America that I would 3D print out and paint myself. And some of my subscribers, now I want to make sure I get your names right, it's Toni, Ryan, and Michael Wuchitech, I believe I'm saying your names right. They set me up with a site called Terrain to STL. And this site generates STL files from anywhere on Google Maps. You just have to set some parameters. And we'll check that out in a minute. I'll show you how it works. And what I did was I picked out an area over in Washington, in the Washington area, Oregon area, that would be really cool that my wife would like. And that would be Mount Rainier. And I set up a small area that would be where I wanted it to generate my STL file. And obviously I generated an STL file. And then once I had the file, I sent it over to Simplify 3D. Now the file came in pretty big, and I'm not really familiar with how this terrain generator works. I just kind of played with the default parameters, moved my little selection area around a little bit, and just made the file. When I brought it over into Simplify 3D, it was much larger than this. This is actually 70% of the actual size of the terrain file. So it's a really cool terrain generator. It generates some really big files. The file itself, it was really detailed. From what I could tell, it had all the detail from the elevation maps that were posted up on Google. Now, before we go too far, it'd be easier for me to explain this if we go over to the website and I show you how this works. So let's head over there right now, and I'll show you how I made this file. Okay, folks, so here we are in the web browser. Here is Terrain to STL, and this is a very cool web-based application. And as you can see, once we click into it, this shows you how it all works. And basically it uses Google Maps. And it uses Google Maps data, and you can see here down on the bottom, it uses the SRTM3 dataset from the year 2000, which has a resolution of about 90 meters on the equator. So I think that's a pretty good resolution considering we're using it for terrain generation and we're not using it to look at things. So if we come over here to the West Coast and we double click a few times until we get Mount Rainier, and there's Mount Rainier right there. So we'll double click until we get it into view, just like you would on Google Maps. So if you come under here, under location, and click on center to view, that'll give you your box. That's the box we're going to create the STL file from. If you come down to model details, you can increase the box size. And I think I had mine at 840. So there's ours, 840. And I'm going to center Mount Rainier right up in there. Oh, went a little bit too close. So we'll center it up nicely. And I believe that's exactly what I grabbed. That's the piece that I actually grabbed. And there's also some other interesting parameters you can adjust in the STL generator. Now, I haven't played with any of these, but I think they're pretty self-explanatory. There's a box scaling factor, which means you can scale the box after you create the STL file, so if you wanted to make it larger. There's also the box rotation. If you wanted to rotate the box, you'll still get a straight-up STL file that is straight, but you're just rotating the selection area that you want to grab. And of course, there's vertical scaling, so if you want to enhance the look of the terrain that you're generating and make it look a little bit more realistic in some of the areas you may be doing, maybe flat, and you want to raise up some areas, that's what that's good for. Next, you have your water and base settings. Now, this water drop, I believe, is the water level, and we're not going to mess with that. And then, of course, your base height, which I believe is the size of the base
before it actually starts printing out the geometry of the topographical file is the size of the thickness of the base, and we have ours set at 2 millimeters. And of course, there is some brief instructions here that kind of gives you an idea of how to actually work the STL generator, but you can really just play around a little bit. Once you have an area you're satisfied with, go ahead and hit create and download. Now the key to this is to not back out of this and reset it or refresh or go to another page on this website. If you are testing out, trying to find the perfect area, what you want to do is hit create and download, and then check the STL file to make sure that's exactly what you want. And then you can come back in here and start messing with the details. Another thing you might want to note is this is the northwest corner coordinations. So that would be the top upper left-hand corner of where the longitude and latitude starts. Now, if you want to repeat this and you have backed out, you want to make note of your longitude and latitude. But if you just keep this open, you should be okay. So once you're satisfied with the area you want to sample, just go ahead, like I said, and hit create and download, which we'll do that here. And it'll prepare a zip file that'll have your STL file inside there, which you can now drag over to your favorite slicing program and get ready for 3D printing.
So as you can see, it's a pretty simple process. There's not a lot of explanation on how to do it. You just kind of have to play around a little bit until you find an area that you like and a size you like. And you do some experimenting because you can just generate some STL files, bring them into either your 3D application or your slicing program and look at how they look before you print them, and then you can go back and adjust some parameters. And I thought it was really cool because it really works off of actual Google topographical data. Now I did notice it was from the year 2000, so it's a little bit older, but the Earth hasn't changed that much, I don't think. There's been no volcanic eruptions as far as I can remember, or anything that would change the surface of the Earth besides a few earthquakes maybe. So I think the data is pretty accurate. Now that you can pretty much drag it anywhere you want, as you saw in the video, all over Google Maps. And once I was done, I took some screen grabs from actual Google Maps of some satellite photography of the mountain so I could have something to reference for painting. And I'll put that image right here real quick. So now I have my reference image for painting. So once we had the file, and I was really happy with what I had generated with the STL file, the terrain to STL file generator, I dragged it over to Simplify 3D and I scaled it down to 70% because I wanted a bit smaller one to try, because I'm going to do a couple of these because this is really cool. And then I set the layer height for 0.2 millimeters. We did 3 top layers, 3 bottom layers, and I only used about 8% infill on the print. We also printed this out at 35 millimeters per second because I wanted to make sure it would print okay, because we are printing it standing up. And I thought that was a better idea. That way I wouldn't have all those weird retraction issues, and it would give me a much smoother print. And the print itself actually turned out amazing. I mean, I did show this to my wife, who's from that area and very familiar with that area, and she was able to identify spots on the terrain that were accurate. And she said it was very, very accurate. And as you can see, the terrain editor or the terrain generator did an amazing job of generating a very, very cool STL file with all the topographical information. I mean, this is very, very detailed. So it's perfect for painting now. And like I said, the print turned out really, really good. There were no problems whatsoever. I did run a change filament command because I am using the last bits that I have of Matterhacker's Pro Series white filament. So I did do a change filament command, and you can see a little bit of a line here on the back. It's not too bad because I am going to paint it. And it didn't show up on the front, so I don't think it was like a layer shift. I think it was just 2 different consistencies of filament because they're 2 different lot numbers. I noticed that on the spools. But other than that, the print turned out awesome. My gMax 1.5 XT Plus did a stellar job on this. I really can't wait to print it and put a lot of detail on it and send it back over to Martin and let him see a really cool area in North America that we generated with the terrain to STL generator. And it's really cool too. On that website, not only can you generate terrain to STL, but there's also a print the moon application where you can select areas very similar to what we showed you, and you can generate STL files for parts of a moon image. So that was really cool too. So the person who actually created this, I want to make sure I get their name right, is Thatcher Chamberlain. I want to give him a shout out because these are some really cool web-based applications for generating terrain files for STL, for 3D printing, or for anything else. I'm sure you could generate an STL file for some sort of CNC machine and actually cut this out of wood or even metal. So there's a lot of variables you could do with that file generator online, so it's really cool. and I'll put that link down in the description so you guys can check it out yourself. And a huge shout out to Toni and Michael, my subscribers, who provided the link to Terrain to STL. Thank you guys. I very much appreciate you guys supporting the channel. This is a very cool terrain generator. I'm definitely going to use it for some other projects. I am going to print this one out a little bit larger too, for ones for myself, so I'm going to probably be painting 2 of these. But for now, this print turned out really, really good. There were really no problems with it whatsoever. There were no layer issues, no extruder issues, and no filament issues. And I can't wait to prime this guy and put some paint on it and put some detail on it and send it over to Martin over at 3DP Iceland so he can have a really cool area of North America he can show off too. Well, that about wraps it up for day 341 of the 3DP 365 project. I hope you guys found this episode interesting and informative, and if you're looking for ways to support the channel, check out those affiliate links down in the description. And of course, don't forget to subscribe to the channel, comment, like, and share those videos, and I'll see you guys tomorrow.